Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Matrix Labs. This is the video number 27 we have been discussing in the previous video. The following, we have been working on the DCDIAG tool and the different tests that this tool implements. We have 30 types of tests that this tool will run to check the health of your domain controller. We have discussed most of these tests, and the previous video have been talking about a special type of domain controller which is called read-only domain controller. And what is this type or special type of domain controller, and in which situation we can use this type of domain controller, and how we can use the DCDIAG tool to check problems with this type or special type of domain controllers. So I will continue working on discovering the DCDIAG different tests. One of these important tests is the DNS test. So if you can go to the DCDIAG URL concerning Microsoft, when we see the description of DNS test through the DCDIAG tool, it's saying that these are enterprise-wide DNS health checks using a couple of protocols, DNS, RPC, and WMI protocol, not run by default. So this is not run by default. I think this will not run if you type DCDIAG, then the server name, then enter. I think this will not be run automatically or by default. So you need to run it separately. Okay, so this is the DNS tests. We will see there is a couple of tests, about 7 or 8 tests concerning checking the health of the DNS. If we go to the parameters, we will see we have 1, 2, 3, 4, 5, 6, 7, 8. So we have about 8 tests, okay, and couple of parameters that will give us some output, or will display the output, or save the output to a log file, and a parameter for verbose, for example. We will see each one of these tests, and we will discuss it and explain it, and we'll give examples on it. So let's see first ChatGPT 4o when we tell it to explain the DCDIAG DNS test. Before that, I need to make an announcement. We all know that Claude now has upgraded its AI model from 3 to 3.5, which is very, very good, and now it's competing with ChatGPT 4o, and actually it surpasses it in all of the tests. So we will see the Claude 3.5 answers, and you will see it is very, very now developed and more appealing to the users. It's very, very good. Well, let's see first the answer of ChatGPT. So here I'm telling it to discuss each one of these tests and give us or explain it in layman terms or in non-technical terms. So let's see the answer of ChatGPT.
Sure, let's break down what this command does in simple terms. Overview. The DCDIAG command is a diagnostic tool used to check the health of domain controllers in a network. The /test DNS part of the command specifically focuses on testing DNS, domain name system settings and configurations. Options explained. 1. Test DNS. This tells the tool to run DNS-related tests. If you don't specify any specific test, it will run all DNS tests by default. 2. Types of DNS tests. DNS Basic. Checks basic DNS functionality like network connectivity, DNS client settings, service availability, and if the DNS zones exist. DNS Forwarders. Does the basic checks and also looks at the forwarders configuration, which are DNS servers that handle queries your server can't resolve. DNS Delegation. Includes basic checks and also ensures DNS delegations, a way to delegate responsibility for a portion of your DNS namespace to another DNS server, are set up correctly. DNS Dynamic Update. Runs basic checks and also verifies if dynamic updates, automatic updates to DNS records, are enabled in the Active Directory zone. DNS Record Registration. Performs basic checks and ensures that important DNS records like address A, canonical name CNAME, and service SRV records are correctly registered. /resolve xname. Does the basic checks and tries to resolve an external DNS name, like a website. If you don't specify a name, it defaults to www.microsoft.com. DNS all runs all of the above tests except for resolving an external name. 3. Additional options /f log file saves all the output results of the tests to a specified log file. S domain controller runs the tests on a specified domain controller. If not specified, it defaults to the local domain controller. Runs the specified DNS tests on all domain controllers in the network. Provides detailed information about the tests, including both successful results and any errors or warnings. XML saves the output in an XML file format, or XSL xslfile.xsl or XSL xslt file.xsl. Applies a style sheet to the XML output for better readability. Practical example. If you run DCDIAG's DNS/DNS basic foutput.txt, it will perform basic DNS checks. Save the results in a file named output.txt. If you run DCDIAG's test/DNSLV, it will perform all DNS tests, show detailed information about each test. This command is useful for system administrators to diagnose and fix DNS issues in their network quickly.
So we can see the answer is not that simple, even though it is trying to explain it in very, very simple terms, but still, if you are not a technical guy, you will not be able to understand what he's talking about. So let's go to Claude and see the answer, because we will see he's giving a much better answer. So let's see the answer of Claude 3.5.
Sure, I'd be happy to explain the DIAG DNS test in simpler terms. DIAG is a tool used to diagnose problems with domain controllers in Windows networks. The DNS, Domain Name System, test is one of its features that checks various aspects of DNS functionality, which is crucial for network communication. Here's a breakdown of the main DNS tests in layman's terms. Basic DNS test, /DNS basic, this is like a health check for your DNS. It makes sure your network is connected, your DNS client is set up correctly, the DNS service is running, and the necessary zones, like address books for the network, exist. Forwarders test, /DNS forwarders, this checks if your DNS server is set up correctly to ask other DNS servers for help when it doesn't know an answer. It's like making sure your phone book has a way to look up numbers from other cities. Delegation test, /DNS delegation, this ensures that responsibility for certain parts of your network's address book is correctly handed off to the right servers. It's like making sure the right office is in charge of the right department's contact list. Dynamic update test, /DNS dynamic update, this checks if your DNS can automatically update its records. It's like making sure your address book can update itself when someone moves. Record registration test, /DNS record registration, this verifies if important network information, like computer names and services, is properly recorded in the DNS. It's like checking if all the important numbers are actually in your phone book. External name resolution test, /DNS resolve ext name, this tries to look up an internet address, by default, www.microsoft.com, to make sure your DNS can communicate with the outside world. It's like checking if you can find a number for a business in another city. All tests, /DNS all, this runs all of the above tests except the external name resolution. The other options let you customize how the test runs and how it reports results. You can save the results to a file, /f. You can test a specific server, /s, or all servers in your network, /e. You can get more detailed results, /v. You can get the results in a format that's easier for computers to read, XML, and style, XSL. This tool is particularly useful for IT administrators to identify and troubleshoot DNS-related issues in their network, which can affect things like email, web browsing, and other network services.
So as we can see here, the answer is more easy to understand, more organized. Okay, so you can see answer of ChatGPT 4.0 is not that good. So 1 point to Claude 3.5. Let's ask ChatGPT 4.0 to explain all of these tests using real-world examples. But let me go further, because I try to give it a certain prompt to give me a good example or a good output. So let me show you all after tweaking my prompt or my question to ChatGPT for all the answer or the final answer that I found it to be very very good to explain the different DNS sets of tests of the DCDIAG. Okay, let's see first. So all of these are my trials to get a good answer. So let's see the final result or the final best answer I have got from ChatGPT. So here, let me tell you. Here I'm telling him now combine your previous answers. Give me a real-world example on a domain named matrix.internal with a PDC named DSM0125 and ADC named DSM0225 and create problems to be solved by each of the DNS tests and simulate output of each test. So let's see the answer here of ChatGPT for all. Okay, let's go, and as you can see here the answer is very very detailed and try to simulate the output of each of these tests. So let's try to read it loudly and see the answer if it is that good or not. Okay, now we can do that.
Matrix.internal domain. Each test targets a different aspect of DNS functionality, helping to ensure that your network remains stable and accessible both internally and externally.
Okay, where is this? Okay, I think it's okay, where it is. Okay, where is the answer? Okay, let's go again and try to see why it is not working. I think let's wait for a moment. So here is the answer. If we try to again,
Matrix.internal domain. Each test targets a different aspect of DNS functionality, helping to ensure that your network remains stable and accessible both internally and externally.
so here I think he is not reading it completely. Okay, let's try to read it in another way. So if we go like that and try to get all of the output, and we can go further. Here you go, this is the answer. Okay, and try to read it loudly like that.
Sure. Here is a comprehensive real-world example for the matrix internal domain with a PDC named DCSM0125 and an ADC named DCSM0225, including specific problems to be solved by each DNS test and the simulated output of each test. Scenario overview. You are a network administrator for the domain matrix.internal. Your network is experiencing various DNS-related issues. You will run different DIAG/test DNS commands to diagnose and resolve these issues on your primary domain controller, DCSM0125, and additional domain controller, DCSM0225. 1. Basic DNS test on the primary domain controller. Problem. Users are experiencing intermittent network connectivity issues and are unable to access internal resources. Command. Copy code. DIAG/test DNS/DNSBasic/S DCSM0125. Simulated output. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM0125 asterisk identified AD forest. Doing initial required tests testing server. Default first site name \DCSM0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM0125 pass test connectivity doing primary tests testing server. Default first site name \DCSM0125 starting test. DNS tests are running and not hung. Please wait a few minutes. DCSM 0125 pass test DNS. 2. Comprehensive DNS test on all domain controllers. Problem. There are widespread DNS issues across the entire network, affecting multiple services and users in different locations. Command. Copy code.
DCDIAG/test, DNS/DNSOL/e/v.
Simulated output. YAML. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM 0125 asterisk identified AD forest. Doing initial required tests testing server. Default first site name \DCSM 0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM 0125 pass test connectivity doing primary tests testing server. Default first site name \DCSM 0125 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for domain controllers, DC. DCSM 0125 test. Forwarders result, pass test. Delegation result, pass test. Dynamic update result, pass test. Record registration result, pass DC. DCSM 0225. Test. Forwarders result, pass test. Delegation result, pass test. Dynamic update result, pass test. Record registration result, passed. DCSM 0125 pass test DNS. DCSM 0225 pass test DNS. 3. Testing DNS forwarders on a specific domain controller. Problem. External website access is slow or unreliable, and users report frequent timeouts when trying to reach the internet. Command. Copy code. DIAG/test, DNS/DNS forwarders/s, DCSM 0225/f, forwarders _test results, txt. Simulated output, also saved to forwarders, fixed. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM 0225 identified AD forest. Doing initial required tests testing server. Default first site name \DCSM 0225 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM 0225 pass test connectivity doing primary tests testing server. Default first site name \DCSM 0225 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for forwarders. Forwarder 8.8.8.8 result. Passed forwarder 8.8.4.4 result. Passed. DCSM 0225 pass test DNS. 4. Checking DNS record registration on the primary domain controller. Problem. Internal services such as email, file sharing, and authentication are not working properly because their DNS records are missing or incorrect. Command. Copy code. DIAG/test, DNS/DNS record registration /s, DCSM 0125/v. Simulated output. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM 0125 identified AD forest. Doing initial required tests testing server. Default first site name \DCSM 0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM 0125 pass test connectivity doing primary tests testing server. Default first site name \DCSM 0125 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for record registration. Address A. Records. DCSM0125.matrix.internal. Registered canonical name. Name. Records. DCSM0125.matrix.internal. Registered service. SRV. Records. Underscore LDAP. Underscore TCP.DC. Underscore MSDCS.matrix.internal. Registered. DCSM0125 pass test DNS. 5. Resolving an external DNS name on the primary domain controller. Problem. Users are unable to access specific external websites, which might be crucial for business operations. Command. Copy code. DIAG/test DNS/DNS resolve ext name /DNS internet name www.example.com/s DCSM0125/v. Simulated output. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM0125 * identified AD forest. Doing initial required tests testing server. Default first site name / DCSM0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM0125 pass test connectivity doing primary tests testing server. Default first site name / DCSM0125 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for resolving external name www.example.com result. Successfully resolved to IP 93.184.216.34. DCSM0125 pass test DNS. 6. Dynamic update test on the primary domain controller. Problem. DNS records are not updating automatically, leading to stale or outdated information in the DNS server. Command. Copy code. DIAG/test DNS/DNS dynamic update /s DCSM0125. Simulated output. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM0125 * identified AD forest. Doing initial required tests testing server. Default first site name / DCSM0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM0125 pass test connectivity doing primary tests testing server. Default first site name / DCSM0125 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for dynamic updates. Dynamic update. Enabled. DCSM0125 pass test DNS. 7. Delegation test on the primary domain controller. Problem. Subdomains or delegated zones are not resolving correctly, causing issues with accessing resources within these subdomains. Command. Copy code. DIAG/test DNS/DNS delegation /s DCSM0125. Simulated output. Mathematica. Copy code. Directory server diagnosis performing initial setup. Trying to find home server. Home server equals DCSM0125 * identified AD forest. Doing initial required tests testing server. Default first site name / DCSM0125 starting test. Connectivity * Active Directory LDAP services check * Active Directory RPC services check * Active Directory DC availability check. DCSM0125 pass test connectivity doing primary tests testing server. Default first site name / DCSM0125 starting test. DNS tests are running and not hung. Please wait a few minutes. Test results for DNS delegations. Delegation check for subdomain. sub.matrix.internal result passed DCSM 0125 pass test DNS. Summary. By running these specific DNS tests, you can diagnose and resolve various DNS-related problems in your matrix internal domain. Each test targets a different aspect of DNS functionality, helping to ensure that your network remains stable and accessible both internally and externally.
Well, I can see even the answer is very organized and is very real. Okay, so you can see the test and the parameters and you can see the simulated output, but still you cannot feel the example. The example is not giving us something we can touch. Okay, if you go, you will see what I mean when we try to see the answer of Clock 3. So if we try to give him the same question, to use real world example, a domain named so and so, a PDC and an ADC, create a problem to be solved by each of these tests. Let's see the answer, even though it is much less, it's not that complicated like ChatGPT 4.0, but I think it's very simple and it's straight to the point. Let's read it and I will show you all, or you will see what I mean. So if you go there and tell him to read it loudly.
Certainly. Let's use a real-world example with the domain matrix.internal and two domain controllers, PDC, primary domain controller, named DCSM0125 and ADC, additional domain controller, named DCSM0225. I'll create scenarios for each DNS test to solve. Basic DNS test / DNS basic problem. Users in the Matrix Corporation are complaining they can't access the company's internal website, intranet.matrix.internal. Solution. Running the basic DNS test reveals that the DNS service on DCSM 0125 has stopped. Restarting the service resolves the issue. Forwarders test / DNS forwarders problem. Employees at Matrix can access internal resources but can't browse external websites. Solution. The forwarders test shows that the DNS forwarders on both DCSM 0125 and DCSM 0225 are misconfigured, pointing to an old, decommissioned ISP DNS server. Updating the forwarders to the correct ISP DNS addresses fixes the internet access. Delegation test / DNS delegation problem. The IT department has set up a new subdomain for the research team, research.matrix.internal, but researchers can't access resources on this subdomain. Solution. The delegation test reveals that the delegation for research.matrix.internal is missing on DCSM 0125. Adding the proper delegation allows access to the research subdomain. Dynamic update test / DNS dynamic update problem. New computers joined to the Matrix internal domain aren't automatically appearing in DNS, causing IT to manually add each new computer. Solution. The dynamic update test shows that dynamic updates are disabled for the Matrix.internal zone. Enabling dynamic updates on both DCSM 0125 and DCSM 0225 solves the problem. Record registration test / DNS record registration problem. The new print server, print.matrix.internal, has been set up, but nobody can find it on the network. Solution. The record registration test indicates that the DNS records for the print server are missing. Manually adding the required A and SRV records for print.matrix internal resolves the issue. External name resolution test / DNS resolve ext name problem. Matrix employees complain they can't access Microsoft.com for software updates. Solution. Running this test shows that external name resolution is failing. Further investigation reveals that the firewall is blocking outbound DNS queries. Adjusting the firewall rules fixes the problem. All tests / DNS all problem. After a power outage, various network services are behaving erratically. The IT manager wants a comprehensive check of the DNS infrastructure. Solution. Running all tests identifies multiple issues. The DNS service on DCSM 0225 failed to start after the power outage. Some zone transfers between DCSM 0125 and DCSM 0225 are failing. A few critical SRV records are missing for domain services. Addressing each of these issues restores normal network operation. These examples demonstrate how the DIAG DNS test can be crucial in identifying and resolving various DNS-related issues in a corporate network environment like Matrix Corporation. Each test focuses on a specific aspect of DNS functionality, helping administrators pinpoint and solve problems efficiently.
So as we can see here, the explanation of Claude 3.5 seems to be more real. Okay, these problems seems to be real, and even if you need step-by-step resolution steps or the solution for each one of these problems, you can ask it to give it or to provide it to you. But this, I think, these examples are more seems to be more touching the real thing, okay, than the one by Chat GPT 4o, even though he's giving a lot or he's putting a lot of effort to give you a simulated output, but still I think the examples of Claude 3.5 is much better. So this is a good thing to use different AI tools to give you different answers. Okay, so this is very good. These are the tests of DNS. If you go to the slides of Mr. Lo van der Poel, we can see these are the different tests, and then he begin making a quick review of the AD components or the Active Directory components. He is giving small explanation. Active Directory is a directory service. What is a directory service? Directory service can be used to provide a central store. So the directory service is a central store for identity and account information, as well as storage of information for other systems and applications. So the Active Directory is a central location. Through it you can manage users and computers for uh, within a network. Okay, so we have computers that are connected together in a network and users that are working on these computers. The Active Directory is a central location that can manage these users and computers and let them share their resources between them, or let the different computers share the resources between them, or make a file server, for example, and share the files on it. So Active Directory is like a central location for managing users and computers. This is in very simple terms. Okay, and also it can control what you can see, or it can control what users can see on their computers. So it is uh, like uh, something like a governor, or like something he is controlling, or like the president, he is controlling different cities or different regions. Okay, so this is in simple terms what is an Active Directory. And then he begins saying that all of the things in the Active Directory are arranged in objects. So you will see, for example, when you open the Active Directory, you will see organizational units, which are objects. Okay, in the Active Directory, they are uh, uh, organized in a hierarchical type, or in something like a tree, or like a form something. So it is a service that stores and organizes objects. We will see what is an object. In Active Directory, you can see a user, this is an object. You can see a computer, this is an object. You can see an OU, this is an object. So these are all the things, or the directory service. AD is a service that stores organized directory objects in a centralized hierarchical data store. So this is very simple. And then he will begin saying what is a directory object. Contains one or more attributes. For example, the user object contains the username, password, and telephone number. Okay, this is an attribute. So you have an object. The object could be a user, could be a computer, could be a group. Each one of these objects have attributes, or let's see, parameters or something. For example, the user object can contain the username of the user, the password of the user, the telephone number, the email. Directory objects are identified by name that is unique among all directory objects in the DS. So every object have a unique name and a unique ID or SID to differentiate it from all of the other Active Directory objects. Are organized in a hierarchical manner. Okay, so this is very simple. Each directory object assigned a name. Okay, this is the relative distinguished name. So every object have a relative distinguished name, and it has attributes. Okay, so this is very simple, and we all know these things. And Mr. Lo van der Poel, he is describing these things, or just revising what is an Active Directory. Okay, then what is the LDAP protocol? It is a way to communicate with the Active Directory. A directory service is accessible, or the Active Directory is accessible via the lightweight directory access protocol LDAP, which have two versions, version 2 and version 3. So he is revising, or let's see, this is the summary of the slides or summary of the video for talking about the DCDIAG tool. So if you go further to the slides, he is saying that physically the Active Directory system is, so he's talking about in a logical way, the Active Directory is a centralized, or it's a system that manages from the logical view. It is a system that controls and manages different users and computers in a network. In a physical view, one or more computer servers that run a directory service. So these, in a physical view, these are servers that are running the Active Directory. Let's consider the Active Directory as a system, or not system, as an application. Okay, refers to as domain controllers. So from physical perspective, okay, we will see that there are servers that are domain controllers. Okay, inside it we have the Active Directory. Okay, from a logical perspective, the Active Directory is a centralized system that manages user computers. From a physical view, the Active Directory is physically on a server named domain controllers, and you can have more than one domain controller. Okay, these computers, if you have more than one domain controller, these computers replicate the contents of the Active Directory so that the client sees a consistent view of the directory. This is very, or this is, as I said, a summary. What is the replication? What is a domain controller? Okay, and how Active Directory have consistent data across domain controllers. Okay, so this is very simple and straightforward. And then he is telling you, the other slide, that there is a lot of protocols that can be used to communicate with the Active Directory. These are all protocols that you can use to communicate with the Active Directory. He's saying that clients can be workstations or can be domain controllers or other servers. So let's see if we can ask ChatGPT to give us some explanation of these protocols. What are these protocols? So if we go further and try to ask ChatGPT to explain these protocols, you need to go further. Let me wait for a moment. So here it is. Let's ask it to explain this in layman terms and see what will be the answer of ChatGPT. If you go there and ask it to explain it.
Sure. Let's break down this information into simple terms. Overview. This slide explains that clients, like computers and users, can communicate with the Active Directory AD using various protocols. These protocols are like different languages or methods that allow clients and the AD to understand and interact with each other. Protocols explained. 1. MSDRSR, Directory Replication Service, Remote Protocol. What it does, helps keep multiple copies of the Active Directory database in sync across different servers. Real-world example. Imagine you have two identical bookshelves in different rooms. This protocol ensures that if you add, remove, or change a book on one shelf, the other shelf gets updated automatically to match. MSLSAD, Local Security Authority, Domain Policy, Remote Protocol. What it does, manages security policies and settings on the network, like password policies and user rights. Real-world example. It's like a security guard who enforces rules about who can enter a building and what they can do inside. 3. MS-SAMR, Security Account Manager. Remote Protocol, Client to Server. What it does, manages user and group accounts, including creating, modifying, and deleting accounts. Real-world example. Think of it as the manager in an office who handles employee records, such as adding new employees, updating their details, or removing them when they leave. 4. MSDSSP, Directory Replication Service, Protocol Extensions for SMTP. What it does, extends the Directory Replication Service to work with email protocols, SMTP, for replication. Real-world example. It's like using email to send updates and changes about the bookshelf to another location, ensuring both shelves stay in sync. 5. Directory Services Setup Remote Protocol. What it does, helps set up and configure directory services remotely. Real-world example. It's like having a remote control, that allows you to set up and organize your bookshelf without being physically present. 6. MSEM, Active Directory Web Service. What it does: provides web-based access to Active Directory services. Real-world example. Imagine you can access and manage your bookshelf from anywhere using a web browser, similar to how you manage your online accounts. Summary. These protocols are various methods that clients use to communicate and interact with Active Directory. Each protocol serves a specific purpose, such as syncing data, managing security policies, handling user accounts, and providing web access. They work together to ensure the smooth operation and management of the Active Directory in a network environment.
Very, very good answer, but let's see the answer of Claude. Okay, so if you go there and try to ask it the same question, let's go and ask it. Here you go. This is the answer. Let's see here how he will explain it. If you go there and ask it to like that and read it loudly.
Certainly. Let me break this down in simple terms. The image is explaining that computers, clients, in a network can talk to the central system, Active Directory, in several different ways. It's like saying there are multiple languages or methods these computers can use to communicate with the main system. Here's a simplified explanation of each. MSDRSR. This is how different parts of the network share and update information with each other. It's like different offices keeping their contact lists in sync. MSLSAD. This is used to manage security settings across the network. Think of it as a way to set and check the rules for who can do what in the company. MSSAMR. This helps manage user accounts. It's like having a tool to add, remove, or change employee information in the company database. MSDSSB. This is a special way of sharing information that works with email systems. It's like making sure the company directory can talk to the email system. Directory Services Setup. This is used to set up and configure the central system. It's like having a remote control to adjust settings on the main company database. MSADDM. This is a web-based way to interact with the central system. It's like having a website where you can view and manage company information. The image also mentions that there are more ways to communicate, but these are the main ones. In essence, this slide is saying that computers in the network have many different tools and methods to talk to and work with the central company database, Active Directory, each serving a different purpose but all allowing for smooth operation of the network.
So simple as it appears, but I think ChatGPT 4o is giving more details, not more detailed, but more organized, or I prefer the answer of ChatGPT 4o. So let's ask it to provide a real-world example to explain all of these protocols. Use real-world examples on a domain named so-and-so with a PDC and an ADC. Explain these protocols, okay? So let's see what is the answer of ChatGPT 4o.
Sure, let's explain these protocols using a real-world example with the matrix.internal domain, a primary domain controller, PDC, named DCS0125, an additional domain controller, ADC, named DCSM0225, and a workstation named WS01. Scenario. Imagine the matrix.internal domain is like a large office building with different rooms and facilities. DCSM0125 is the main office, PDC. DCSM0225 is a secondary office, ADC, that helps the main office, and WS01 is a workstation where an employee named John works. Protocols explained with real-world examples. 1. MSDRSR, Directory Replication Service, Remote Protocol. Function keeps the Active Directory database synchronized across DCSM0125 and DCSM0225. Real-world example. Think of DCSM0125 and DCSM0225 as two identical filing cabinets in different rooms. Whenever a document is added, removed, or updated in DCSM0125, main filing cabinet, the change is automatically copied to DCSM0225, secondary filing cabinet, to ensure both have the same information. 2. MSLSAD, Local Security Authority Domain Policy Remote Protocol, function manages security policies like who can access certain areas and what actions they can perform. Real-world example. It's like the security team that enforces building rules, such as ensuring only authorized personnel can enter secure areas or specifying what actions employees can perform based on their roles. 3. MSSAMR, Security Account Manager, or protocol client to server, function, handles user and group account management, such as creating, updating, or deleting accounts. Real-world example. Imagine DCSM0125 is HR. John needs access to new project files, so HR updates his access permissions. This protocol allows HR, DCSM0125, to manage John's account details, ensuring he can access the necessary files from his workstation, WS01. 4. MSDSSP, Directory Replication Service, Protocol Extensions for SMTP, function, extends the replication service to use email protocols for updates. Real-world example. It's like using emails to send updates about changes in the main filing cabinet, DCSM0125, to the secondary filing cabinet, DCSM0225. This ensures that any updates made via email are also reflected in both filing cabinets. 5. Directory Services Setup Remote Protocol function helps set up and configure directory services remotely. Real-world example. If IT needs to set up new filing systems or reorganize existing ones, they can do it remotely from DCSM0125 without physically being at each filing cabinet. This is like having a remote control to configure and set up office arrangements. 6. MSADM Active Directory Web Service function provides web-based access to Active Directory services. Real-world example. John can access and manage his account settings or request access to new resources via a web portal from his workstation, WS01. It's like logging into an online system to manage work-related settings or requests. Example usage. 1. Keeping data synchronized. MSDRSR. When IT updates user permissions on DCSM0125, the changes are automatically synchronized with DCSM0225, ensuring consistency. 2. Managing security policies. IT enforces a policy that all users must change their passwords every 90 days. This policy is applied across the domain via DCSM0125. 3. Handling user accounts. John is given access to a new project folder. IT updates his account on DCSM0125, and these changes are reflected on WS01. 4. Replicating via email. MSDSSP, changes to user data made via email updates are synchronized between DCSM0125 and DCSM0225. 5. Remote setup and configuration. Directory Services Setup Remote Protocol. IT sets up a new department in the Active Directory from DCSM0125 without needing to visit each server physically. 6. Web-based management. MSADM. John accesses a web portal from WS01 to request access to additional resources, and IT approves it through the web interface provided by DCSM0125. Summary. These protocols enable efficient and secure communication and management of the Active Directory across the matrix.internal domain. They help synchronize data, enforce security policies, manage user accounts, replicate updates, set up services remotely, and provide web-based access, ensuring a smooth and well-organized network environment.
So we can see the answer is better, or it's good, but here he is mistaken that the replication is not done by email updates. It's done by or through email protocols, or through the protocol used to send emails. Okay, not sending emails. Okay, so this is one thing. And as for the web portal, I think he is not getting it that right. John access a web portal, request access to additional resources. Anyway, I think the answer is good, but let's see the answer of Claude 3 and see the answer here. Okay, so okay, let me do it like that. Okay, let's do it like that. Just a moment. So here we go. Let's read it loudly.
Certainly. Let's use the Matrix Corporation example to illustrate how these protocols work in a real-world scenario with the domain matrix internal primary domain controller DCSM0125. additional domain controller DCSM0225, and the workstation WS01. MSDRSR, Directory Replication Service Imagine DCSM0125 and DCSM0225 as two librarians managing the company's employee directory. When a new employee, NEO, is added to the system on DCSM0125, MSDRSR ensures that DCSM0225 gets the same information quickly. This way, both librarians always have the most up-to-date information. MSLSAD, Local Security Authority, the IT admin at Matrix Corp, uses this to set a new policy that all passwords must be changed every 60 days. They configure this on DCSM0125, and it's automatically applied to all computers, including WS01. When Neo logs into WS01, he'll be prompted to change his password if it's older than 60 days. MSSAMR, Security Account Manager, when Trinity from HR needs to create a new account for a new employee, Morpheus. She uses a tool on her computer that communicates with DCSM0125 using MSSAMR. This protocol allows her to add Morpheus's details to the system securely. MSDSSB, Directory Replication Service Protocol Extensions for SMTP. Matrix Corp has a branch office that's connected via a slower internet link. MSDSSB allows DCSM0125 to replicate directory changes to the branch office's server using email protocols, ensuring the remote office stays updated even with a less reliable connection. Directory Services Setup Remote Protocol. When the IT team needs to set up a new domain controller, DCSM0325, they use this protocol to remotely configure it, copying settings from DCSM0125 without having to be physically present at the new server's location. MSADDM, Active Directory Web Service. The Matrix Corp IT team has created a web portal where employees can update their own contact information. When Neo uses this portal from WS01 to update his phone number, the web application uses MSADDM to communicate these changes securely to DCSM0125. In all these scenarios, WS01 and other client computers in the Matrix internal domain can interact with the Active Directory primarily through DCSM0125 and DCSM0225 using these various protocols. Each protocol serves a specific purpose, allowing for secure and efficient management of the entire network, from user account management to policy enforcement and directory synchronization. This multi-protocol approach ensures that no matter what task needs to be done, whether it's updating information, managing security, or setting up new systems, there's a secure and efficient way for the clients and servers in the Matrix Corporation to communicate and keep everything running smoothly.
So we can see here the answer is much better, or I think it's much better than ChatGPT 4o. So we will continue with the slides of Mr. Lovanderpool. So now we have seen the clients, how they communicate with the Active Directory through using different protocols. And then he's saying, or the other slide, saying network related operations depend on domains for locating a domain controller using DNS and NetBIOS, okay, joining a domain by creating an account via the security account manager remote procedure call, okay, joining a domain by creating an account via LDAP, removing a domain member. So these uh, steps cannot be done unless there is network. Okay, so here locating a domain controller using DNS and NetBIOS, this will not be done unless you have a network of computers joining together or joined together. Okay, you cannot join a PC to the domain or create a user on the domain unless, or the domain controller, unless you have a network or the domain controller is networked or added or within a network, so you can access it through your workstation. Joining a domain, okay, you should be in a network that is or your workstation should be in a network and the domain controller should be in the same network, so you can communicate between between each other, or between between you and the domain controller. Removing a domain member, so this is very simple explanation. And then he's giving us something. What is a global catalog? This is a feature that is added to the domain controller. What is this feature? Contains a partial replica of all of the Active Directory databases. So any domain controller will have a partial replica, or let's see, a snapshot okay, of all of the objects in the Active Directory within a forest. So for example, if a domain controller is a global catalog, through it you can query or request an information about any object within the forest. Okay, so any domain controller that is holding the global catalog feature, okay, he can uh, he can be queried for any object within the forest, even though he is a domain controller within certain domain. Okay, this domain within a forest, okay, but he has info about all of the objects in the other domains in the forest. Okay, so GC holds a replica of every object in the directory, but with only a small number of attributes. So this is a good thing to have, or every domain controller holding this feature can know the other objects in the other domains. So this is very, very good. So you can query the domain controller for any object within the forest. So this is very, very good thing to have. And actually, in all of my labs, or when I set up a domain controller, I have this feature enabled. Okay, on all of my domain controllers. Okay, so here is saying troubleshooting Microsoft tools for diagnostic Active Directory issues, deep dive into the results of DCDIAG. Okay, so this is like the summary, as I've said before. Time synchronization Active Directory. Each host in the Active Directory needs to be synced with the same time. So all of the servers on the workstation will think sync their time with the time of the primary domain controller. And the primary domain controller should have its time synced with an external time server which is accurate. Okay, real headaches for amends if the time is not accurate and everyone on the network agrees with the same time. So this is something you need to know. A problem will arise if the timing of the domain controller with the clients is not correct. Okay, so here we can see that we have discussed this before. These are very important protocols that without it the Active Directory will not work. We have discussed this in the beginning of the lab, or the beginning of the series, or beginning of the video discussing DCDIAG. We have seen the protocols LDAP, RPC, DNS, and TCP/IP, and we can add the corpus as well, adding this with it. Okay, 1, 2, 3, 4. We have 5 protocols: LDAP protocol, RPC protocol, DNS, TCP/IP, and corpus. So to the end of the video, or we will uh, end the video by discussing this way, or how the corpus authenticates the users to the domain. This is the process. Let's ask ChatGPT to explain the process, and ask also Claude to explain the same. So let's go and ask, let's go there and ask it here as to explain this graph in layman terms. Let's see how he will explain it.
Sure, let's explain this process in simple terms. Overview. This diagram shows how Active Directory AD uses a system called Kerberos for authentication. It ensures that users and services can securely prove their identity to each other over a network. Key components. User, computer client, the person or device trying to access a resource. Windows Domain Controller, a server that manages network security containing Kerberos components like the Key Distribution Center, KDC, which has 2 parts: the Authentication Server, AS, and the Ticket Granting Server, TGS. Resource Server, the server that has the resource, like a file or service, the user wants to access. Steps explained. 1. Request TGT, Ticket Granting Ticket. The user client asks the domain controller DC for a TGT, which is like a special pass to prove their identity. 2. TGT plus session key. The DC verifies the user's identity and sends back a TGT and a session key. The TGT is encrypted and can only be read by the TGS. The session key is a temporary key used for this session. 3. Request ticket plus auth. Now that the user has the TGT, they use it to request access to a specific resource. They send the TGT and an authenticator, proof that they are who they say they are, to the TGS. 4. Ticket session key. The TGS checks the TGT, verifies the user, and sends back a ticket and a session key for the resource server. The ticket is like a permission slip for the resource server. 5. request service plus auth. The user sends the ticket and an authenticator to the resource server to prove they have permission to access the resource. 6. Server authentication. The resource server checks the ticket, verifies the user's identity, and allows access to the resource. Summary. In simple terms, Kerberos works like a series of checks and passes. 1. The user asks for a pass to prove their identity. 2. The DC gives them a pass and a key for the session. 3. The user requests permission to access a resource using the pass. 4. The DC gives them a permission slip for the resource. 5. The user shows the permission slip to the resource server. 6. The resource server verifies the slip and lets the user access the resource. This process ensures that both the user and the services can trust each other's identity, keeping the network secure.
So this is very, very good. As we can see here, that the answer is verified, and it's very, very simple. If you go to Claude and try to ask it the same question, okay, if you go there and ask it to explain it in layman terms, but I will stop at this here and continue, but give me a moment. So let's continue, guys. Here we will see the answer of Claude 3.5 concerning the same image, which is describing the process of the Kerberos authentication. So let's read it loudly.
This image shows how Active Directory, AD, uses Kerberos for authentication, which is like a secure way of proving who you are on a computer network. Let's break it down step by step. Your computer asks the main security guard, Windows Domain Controller, for a special pass, called a TGT. The security guard gives you this pass, TGT, along with a secret code, session key. When you want to use a service, your computer asks for another ticket, showing the first pass as proof. The security guard gives you this new ticket, which is like a specific permission slip for that service. To use the service, like accessing a file server, your computer shows this new ticket to prove you're allowed. The service checks with the security guard to make sure your ticket is real. This whole process happens automatically and quickly in the background. It's designed to keep your network safe by making sure only the right people can access different parts of it without you having to type in your password for every single thing you do. The main security guard, Domain Controller, has two important jobs here. It's both the ticket office, KDC, that gives out passes, and the person who decides if you're allowed in, AS plus TGS. This system is more secure than just using passwords because these tickets expire quickly and are hard to fake.
So this is very, very simple and straightforward simplification of the Kerberos authentication. As you can see here, just I am opening the screenshot just to see the whole process. Okay, so this is very, very simple. So we need a real world example to explain this process. So let's see ChatGPT 4o when I ask it to give us a real world example. For example, we have a domain, we have two domain controllers, a file server and a workstation. So let's see the whole process being explained through a real world example.
Sure. Let's explain the Kerberos authentication process using a real-world example with the matrix.internal domain. In this scenario, we have primary domain controller PDC DCSM0125, additional domain controller ADCSM025, file server FSSM15, workstation WS01. Scenario user John is logged into the workstation WS01 and wants to access a file stored on the file server FSSM0125. Step-by-step process. 1. Request TGT, ticket granting ticket. What happens? John, on WS01, wants to prove his identity to the domain. WS01 sends a request to the primary domain controller, DCSM0125, asking for a TGT. Real world. John asks DCSM0125 for a special pass to use within the matrix.internal network. 2. Receive TGT plus session key. What happens? DCSM0125 verifies John's credentials, like his username and password. Once verified, DCSM0125 sends back a TGT and a session key. The TGT is encrypted and can only be read by the ticket granting server, TGS. Real world, DCSM0125 gives John an encrypted pass, TGT, and a key to use during this session. 3. Request service ticket. What happens? Now that John has the TGT, he uses it to request access to the file server FSSM0125. W01 sends the TGT and an authenticator, proof that John is the one using the TGT, to the TGS, part of DCSM125. Real world, John shows his special pass, TGT, to the ticket office, TGS, to get permission to access the file server FSSM125. 4. Receive service ticket session key. What happens? The TGS verifies the TGT and the authenticator. Once verified, the TGS sends back a service ticket and a session key for FSSM0125. Real world, the ticket office TGS checks John's pass and gives him a permission slip, service ticket, and a key to use with the file server. 5. Request file access. What happens? John, on win 1, sends the service ticket and an authenticator to FSSM0125 to prove he has permission to access the file. Real world, John shows his permission slip, service ticket, to the file server FSSM0125 to access the file he needs. 6. Server authentication and access granted. What happens? FSSM0125 verifies the service ticket and the authenticator. Once verified, it allows John to access the file. Real world, the file server FSSM0125 checks John's permission slip, confirms it's valid, and lets John access the file. Mesh visualizing the process. Workstation, WS01, domain controller, DCSM0125 and DCSM025. File server, FSM01. 1. WS01. Hi, DCSM0125. I'm John. Can I get a pass, TGT? 2. DCSM. Sure, here's your pass and a key for this session. 3. Thanks. Now I need permission to access FSSM0125. Here's my pass, TGT. 4. DCSM0125s. Got it. Here's your permission slip, service ticket, and a key for FSSM0125. Hey, FSSM0125, here's my permission slip and my proof, authenticator. 6. Everything checks out. You can access the file. Summary. In this example, John uses Kerberos authentication to securely access a file on FSSM0125 in the matrix.internal domain. The process involves multiple steps where tickets and keys are exchanged to verify identities and permissions, ensuring that both the user and the services can trust each other.
So this is a very good example, and ChatGPT-4 tries to make it more engaging, but I think Claude 3.5 is exceeding or excelling in this matter. Let's see the answer here also if I'm trying to give him the same question. So if we go further down, and then we can read this thing loudly. Okay, here we go. More action, then read it loudly.
Certainly. I'll explain this using a real-world example with the domain and servers you've specified. Let's imagine an employee named Neo who works at Matrix Corporation. Neo turns on his computer, WS01, and logs into the Matrix internal domain. His computer sends a request to the primary domain controller, DCSM0125, saying, "Hey, Neo's here and wants to log in." DCSM0125 checks Neo's credentials and says, "Alright, Neo's legit." It gives Neo's computer a special pass, TGT, and a secret handshake, session key. This is like Neo getting an ID badge and a secret PIN for the day. Later, Neo needs to access some files on the file server, FSSM0125. His computer WS01 says to DCSM0125, Neo wants to access FSSM0125. Here's his ID badge, TGT, to prove it's him asking. DCSM0125 checks the badge and gives WS01 a new, specific ticket for accessing FSSM0125. This is like Neo getting a special file room access card. Neo's computer, WS01, then goes to the file server, FSSM0125, and says, Neo wants in. Here's his file room access card. FSSM0125 doesn't just trust this card immediately. It quickly checks with either DCSM0125 or DCSM0225, the additional domain controller, to make sure the card is legit and hasn't expired. All of this happens in seconds, behind the scenes. Neo just sees that he logged in and can now access his files. If the primary domain controller, DCSM0125, is busy or down for maintenance, the additional domain controller, DCSM0225, can step in and handle any of these requests. This ensures that Neo and his colleagues can always access what they need, even if one server is having issues. This system is secure because Neo never actually sends his password across the network after the initial login. The cards, tickets, given out expire quickly. Each card is specific to a particular service, so if someone somehow stole Neo's file room access card, they couldn't use it to access, say, the email server. This whole process, powered by Kerberos, keeps Matrix Corporation's network secure while making it easy for employees like Neo to do their jobs without constantly re-entering passwords.
So this is a good example and more clear than the other said by ChatGPT 4o. Now we have a question. What is the difference between ticket grant ticket and the service ticket? This obvious. Ticket grant ticket, it's like a general pass or general permission to access the network, but the service ticket, it is to access a certain resource. So the general pass or the ticket grant ticket, you can access the network, okay, but you cannot access any service unless, or any file, unless you have a service ticket. So let's see the answer of ChatGPT 4o and see what is the difference between the ticket grant ticket and the service grant ticket.
Great question. Let's break down the difference between a ticket granting ticket, TGT, and a service ticket in the context of Kerberos authentication. Ticket granting ticket, TGT, purpose. The TGT is used to prove the user's identity to the Key Distribution Center, KDC, so that the user can request access to various services without needing to repeatedly enter credentials. Function. When a user first logs in and needs access to network resources, they authenticate with the KDC, specifically the authentication server AS part of the KDC. Upon successful authentication, the KDC issues a TGT. This ticket is encrypted with the KDC's secret key, ensuring its integrity and authenticity. The TGT contains the user's identity and a session key, but it doesn't specify any particular service. Instead, it allows the user to request service tickets for specific services without having to re-authenticate each time. Lifetime. The TGT is typically valid for a certain period, e.g. 8 hours. After it expires, the user needs to obtain a new TGT by re-authenticating. Service ticket. Purpose. A service ticket allows the user to access a specific service, like a file server, email server, etc., securely. Function. When the user needs to access a specific service, they present their TGT to the KDC, specifically the Ticket Granting Server, TGS part of the KDC, to request a service ticket. The TGS validates the TGT and issues a service ticket for the requested service. The service ticket is then presented to the service the user wants to access, e.g. the file server. The service ticket includes a session key that both the user and the service can use to secure their communication. Lifetime. The service ticket is typically valid for a shorter period than the TGT, e.g. 10 minutes to a few hours. It is valid only for the specific service for which it was issued. Key differences. 1. Purpose. TGT used to prove the user's identity to the KDC and request service tickets without re-authenticating. Service ticket used to access a specific service securely. 2. T issued by the authentication server AS component of the KDC. Service ticket issued by the ticket granting server TGS component of the KDC. 3. Scope. General purpose ticket allowing the user to request service tickets. Service ticket. Specific purpose ticket allowing access to one particular service. 4. Validity. TGT. Typically valid for a longer period, e.g. 8 hours. Service ticket. Typically valid for a shorter period and for a specific service. Real-world example in matrix.internal. 1. T example. John logs into WS01 and requests a TGT from DCSM0125. DCSM0125 authenticates John and issues a TGT. John now has a TGT that he can use to request access to other services without re-entering his credentials. 2. Service ticket example. John wants to access a file on FSSM125. John uses his TGT to request a service ticket for FSSM0125 from DCS0125. DCSM0125 verifies the TGT and issues a service ticket for FSSM0125. John presents the service ticket to FSSM0125 and gains access to the file. By using TGTs and service tickets, Kerberos ensures secure and efficient authentication and authorization across the network, minimizing the need for repeated logins and enhancing security.
Very, very good example and very, very, very good explanation actually. I like this answer. Let's go to ask Claude to explain the same question.
Great question. Let's break down the difference between a ticket granting ticket, TGT, and a service ticket in simple terms. Ticket granting ticket, TGT. Purpose. It's like a master pass that allows you to request access to specific services. Obtained. You get this when you first log into the domain, e.g., when Neo logs into matrix.internal. Issuer. It's issued by the Authentication Service, AS, part of the Key Distribution Center, KDC, on the domain controller, e.g., DCSM0125. Lifespan. Usually lasts for several hours, typically 10 hours by default in many systems. Usage. You don't use this directly with services. Instead, you use it to get service tickets. Analogy. Think of it as a VIP wristband at a festival that lets you ask for passes to individual attractions. Service ticket. Purpose. It's used to access a specific service or resource, like the file server FSSM0125. Obtained. You get this by presenting your TGT to the Ticket Granting Service, TGS, and requesting access to a specific service. Issuer. It's issued by the Ticket Granting Service, TGS, part of the KDC. Lifespan. Typically shorter than a TGT, often around 8 hours. Usage. Presented directly to the service you want to access. Analogy. This is like getting a specific ride pass at the festival using your VIP wristband. Key differences. Scope. TGT is broad, for the whole domain, while service ticket is specific to one service. Frequency of obtaining. You get one TGT per login session, but many service tickets is needed. Direct use. You never present the TGT to a service, but you do present service tickets directly to services. In our matrix.internal example, when Neo logs in, his computer gets a TGT from DCSM0125 or DCSM0225. When Neo tries to access files on FSSM0125, his computer uses the TGT to request a service ticket specifically for FSSM0125. Neo's computer then presents this service ticket to FSSM0125 to gain access. This two-ticket system enhances security by limiting exposure of the long-term TGT and providing granular control over access to individual services.
So as we can see here, the the answer of Claude also is very, very good, 3.5. So by this we have finished the slides for Mr. Lovanderpool concerning the DCDIAG tool. As you can see here, this is his website, this is his channel. These are the languages that are translated, or his videos are translated to all of these languages. So I urge you all to subscribe to Tech Savvy Production YouTube channel. So the next video we will discuss another video for Mr. Lovanderpool discussing the RIP admin tool, which is a very, very important tool to solve and see problems concerning the Active Directory database replication. So until the upcoming video, hope this video is informative for you all, and thank you all for viewing. Thank you so much.